Okay, now the question is, which algebraic expression of these four is a polynomial? Let's first talk about what even is a polynomial. A polynomial is an equation of terms where you have x to the power of n with some type of like coefficient. Let's call that c of I, because you're going to have different coefficients for each one of your terms. Let's actually write that on a different line so it's just a little bit clearer. Where you have like a constant or a coefficient multiplied by x to the power of some n, and you add them all up. This sigma represents a summation. And you cannot have n has to be greater than or equal to 0, meaning that you're not allowed to have negative powers for n in your polynomial. That's going to be the main thing that we can use to disqualify some of these things in here. Oh, and also n is an element of the integers, meaning that fractional okay, this z is often used in mathematics to represent integers. That just means like we can't have like x to the power of 0.221, something like that. You have to have like regular whole non-decimal numbers in the power. Okay, so let's see what we can let's take a look at our options and see what we can disqualify here. So the first one, so a, is 4x squared, looks good so far, minus 3x, that's x to the power of 1, plus 2 divided by x. Now 2 divided by x is equal to 2 times x to the power of negative 1. Those two are equal. So because we have a negative 1 here, and the rule for polynomials is that you strictly have powers that are positive and non-fractional, you know that this has to be disqualified. So A, no. It is not A. Okay, now let's check for B. B, here we have negative 6 x to the power of 3 plus x squared minus the root of 5. Hey, all of these powers are positive. None of them are negative. None of them have fractions. So B, so far, passes the test. Now, don't get confused here, because you do see like a root, and roots do correspond to like the root of 5 is equal to 5 to the power of 1 over 2. But that's okay, because the power here is not attached to an x. So all the x's have powers that are positive whole numbers. So B passes the test. Now let's take a look at C. So C, we have 8x squared plus the root of x. And like I mentioned here, the square root is equivalent to a power of the power 1/2. This we have 8 times x to the power of 2 plus x to the power of 1/2. Now see, that power to the 1/2, that breaks the rule. That is 0.5. So that breaks the polynomial rule, because all the powers on x have to be positive whole numbers. So that breaks the rule. It's not C. But I can see that it's not C. You see? Okay, so let's take a look at D. Oh, and D is another one of those situations where we have negative 2x to the power of 4 plus 3 over 2 times x, which is really, when you have an x downstairs on the fraction, that just means like it is, like its regular power is actually negative when you bring it upstairs. So let's bring the x from the downstairs denominator of the function and we can bring it upstairs. So we're going to have negative 2x to the power of 4 minus 3 over 2 x to the negative 1. Uh-oh, negative power. That's a rule breaker, so it's not D. So the only thing that didn't break the rule, that's B. And I guess it wasn't entirely necessary for us to prove that C and D are rule breakers, but you know, if we see that that A, C, and D are rule breakers and B is the only one that's not a rule breaker, that means the answer, that's got to be B. Big B. And yep, they say B is the only one that is a polynomial, so we can confirm that this question is good. Okay, and I guess that was the last question. Time flies when you're having fun, as the old saying goes. Okay.